Question number 71. A qualitative measure of the stability of an ionic compound is provided by. First is electron gain enthalpy of non-metal only, ionization enthalpy of metal only, sum of electron gain enthalpy of non-metal and ionization enthalpy of metal only, and the fourth option, enthalpy of ionic lattice formation.
In ionic solids, the sum of electron gain enthalpy and the ionization enthalpy may be positive, but still the crystal structure gets stabilized due to energy released in the formation of crystal lattice. And on that basis, the actual term that is a qualitative measure of the stability of an ionic compound is provided by enthalpy of ionic lattice formation.
This is the correct statement for this question, and that's the answer for this also. Option 4. After this, the next question, question number 72. A sample of drinking water contains chloroform at a level of 15 ppm, that is parts per million by mass. The percentage by mass of chloroform in the sample is. So basically, the parts per million value for this chloroform is given. That is 15 parts per million, and that is equal to weight of chloroform, that's solute here, upon the weight of solution. And if we talk about parts per million, that's why here should be 10 raised to the power 6. Now, it can also be written as the weight of solute upon the weight of solution. That can be written as 15 into 10 raised to the power minus 6. This is the ratio of weight of solute to the weight of solution. Now what we need to check here, the percentage by mass of chloroform in the sample. So percentage by mass of chloroform, that is CHCl3, can be calculated with the help of weight of chloroform, that's a solute here, upon weight of solution into 100, because percentage we need to calculate. Weight of solute by weight of solution, the value we already know, that is 15 into 10 raised to the power minus 6. Along with that, 100 you need to apply here, multiply. That will be 15 into 10 raised to the power minus 4%. And that is the answer. If it is the answer, the correct option is option 1. So I'll write here. I hope this question is also clear to you. Now let's move on to the next question. Here's the question number 73. The radius of first orbit of Be3 plus is. In this simple question, you have to just find out the radius of first orbit of Be3 plus. In this case, we know that you can find out the radius for nth orbit, that is equal to 0.529 to n square by z. And if we talk about Be3 plus ion, for this particular ion, the value of n is 1. And the value of z for this case is 4. And if it is so, the radius would be 0.529 into, the n value is 1 square, n square by 4. And this is an angstrom. Now, this would be 0.529 into 0.25 angstrom. And if it is so, the correct answer is option 4. So I'll mark here correct answer. Now, after this, the next question. Question number 74. Consider the process. The process is combustion of carbon to give you carbon monoxide, the first one. The second is Fe2O3 is reacting with 3CO. Carbon monoxide is there, and 2 mole of Fe and 3 mole of CO2 are produced. The volume of O2 required at STP, which can produce sufficient carbon monoxide to reduce 1 gram Fe2O3. Molar mass of Fe2O3 is also given, that is 160 gram per mole. In this particular case, we have the two reactions. One is Fe2O3 is combining with 3CO to give you 2Fe plus 3CO2. in this particular case, we have to just find out that amount of oxygen that is required to produce sufficient amount of carbon monoxide to reduce Fe2O3. So first we need to find out the amount of this carbon monoxide. As per the given equation, we can see that 1 mole of Fe2O3 needs 3 moles of CO. It means if we have the moles of Fe2O3 given, then we can find out the required amount of carbon monoxide. So 1 mole needs 3 mole of CO and the given moles are 1 gram is the amount given, molar mass is 160. These are the given moles of Fe2O3. If you have this much number of moles, then the required amount of carbon monoxide would be 3 into 1 by 160 mole of CO. These are required. Now, we know that as per first equation, as if you look here, that 2 mole of CO are produced by 1 mole of O2. So, we need 3 into 1 by 60 mole of CO. So, in that case, there would be 1 by 160 mole of CO requires 3 into 1 by 60 divided by 2 mole of O2. And we know that 1 mole is 22400 ml. So, the volume of O2 required would be equal to 3 by 2 into 1 by 160 into 22400 ml. This much amount of oxygen is required. And if you solve this whole, you will find out that the obtained value is required volume of O2 on calculation is 210 ml. And this is the answer for our question, option 1. That's the correct answer. I hope this question is clear to you. Let's take the next question. Question number 75. Molecular weight of a compound containing 15% beryllium by mass is 2700 U. The number of beryllium atoms present in one molecule of the compound is. Atomic mass of beryllium is also given, that is 9U. Simply in this question, we have the molecular weight of the compound. Is 2700 U. Or simply you can say this is the weight of one molecule. So, weight of one molecule of that compound is 2700 U. One molecule contains 15% of beryllium. The mass of beryllium in one molecule of the given compound would be 15% of this 2700. So it is 2700 into 15 divided by 100 U. This is the total mass of beryllium in one molecule. But we know that the atomic mass of beryllium, that's given in the question, that is 9U. So simply the total number of atoms of beryllium in one molecule are equal to 2700 into 15 divided by 100. It would also be divided by 9. And if you solve this, 3 into 15, that would be 45 atoms total. So the correct answer is option 2. And yes,